instructions before this class. So in case after completion of this, since the Zoom session will have only 40 minutes of time, so if this session is closed, so you people please do join again. So I will take approximately 10 to 15 minutes more for this day. Okay, so please do join after if the session is closed in between. Meanwhile, CR, please do take the attendance of in the second session, not in the first session. Okay. So CRs of both the section, both the colleges, that is for SANC and as well as ACID. Please do take the attendance of the screenshot and send it to me for the second session. Okay, not for the first one, because people will come for the first and they will skip for the second. That's the reason. So anyhow, that's all for the instructions.
Recording in progress.
Okay, so just a recap of our yesterday's class. So that is, we have seen with the dipole. What do you mean by a dipole, and definition of a dipole. And after that, we have seen about the dipole moment, which we have given by the formula, that is P is equal to Q into D. Okay, so just wait. So here P is equal to Q into D, which is known as the dipole moment. Later, we have gone with one of the important concept of electric potential due to dipole. Okay, so electric potential due to dipole. Here we have seen about two cases. Case one, so that is if with respect to the location of P. So here we have taken P at finite, as well as we have taken P at infinity. Okay, so for finite we have obtained the equation. First of all, we have got this equation. Later, we have assumed the point P. Whatever the point P is there, we have considered at infinity. And later, we have done some modification for the diagram. And later, we have proceeded. And finally, we have got this equation, that is Vp is equal to, so Qd cos theta whole divided by 4 pi epsilon naught r square. Okay, so this equation I will make use of now for the next derivation, but later we have made the use of unit vector concept as well as a dot product concept, and finally got the equation, that is electric potential due to dipole at infinity. Okay, so that is V is equal to P bar dot R bar by 4 pi epsilon naught into R square. So this is the way. And now here above we have got what? Potential. So electric potential. So now we need to obtain for electric field intensity. So electric field intensity. And we know that we have the relation between electric potential V and electric field intensity E by what? So we have already got the relation between them by using Maxwell's second equation. So which is given as, so E is equal to minus del of V. Okay, so E is equal to minus del V. So therefore, we are going to take the formula that we have already derived, that is Vp is equal to, so Qd cos theta divided by 4 pi epsilon naught r square, and we are going to apply what? Del operator on it. Okay, so del operator on it. But before applying the del operator, so see here, we know that del operator in our previous classes, I have already given the formula with respect to rectangular coordinate system, so cylindrical coordinate system, and as well as a spherical coordinate system. So it is having a different formulas for with respect to different coordinate systems. But here, in order to have the value for v, or the in order to derive the expression for v, we have to apply the del operator on this equation, on this equation. So therefore, we should come to know which formula we have to apply, which del operator, that is either we have to use rectangular or cylindrical or spherical. So for that, I am going to explain now. So as we have got for a dipole. So dipole is nothing but 2 point charges minus q and plus q. So if they are separated by a distance d.
Morning, sir.
Any problem?
No, sir.
Okay, okay then. So separated by a distance d, then this all together it is called as a dipole. So see here, we are talking with respect to point charges. Okay, point charges. We know that point charges are very, very small size. Okay, so these are very, very small. That means they will be in the form of a nano sizes. Okay, nanometer sizes. So since there are 2 point charges, again this will be in the minute size, very minute. Okay, so therefore you can consider this dipole, whatever the dipole it is forming, we can approximate to a point charge. Point charge or 2 point charges. Again, they will be of very small. Okay, so therefore, whatever the field around it, whatever the field around this dipole will be in the form of a sphere. Will be in the form of a sphere. So therefore, here, in order to apply this formula on the del operator, if you want to apply the del operator on this formula, so which is nothing but we are applying for a dipole. So dipole, for a dipole, the field around it will be in the form of a sphere, will be in the form of a sphere. What we are going to take? We are going to take the formula for del for spherical coordinate system. So del operator for spherical coordinate system. Okay. So what is the del operator for spherical coordinate system here? So if you want, you can go back to your previous pages and verify. So del is equal to spherical coordinate system. The spherical coordinates are r, theta and phi. So we will write the del operator with respect to r, theta and phi only. So del is equal to dou by dou r of ar bar plus 1 by r. Okay, so plus 1 by r, dou by dou theta of a theta bar plus 1 by r sin theta dou by dou phi of a phi bar. So this is the formula for del in spherical coordinate system. Okay, so now we are going to take what? So E is equal to del of V. So E is equal to del of V. So what is del?
ఫోన్ చేస్తున్నాడు.
Hey. So you guys please try to maintain the mute, whether you, I don't know how many of you are listening or not, but please don't disturb the other candidates. So now we are going to apply the del operator. So del is dou by dou r of ar bar plus 1 by r, dou by dou theta of a theta bar plus 1 by r sin theta of dou by dou phi of ar bar. What is V here? So V is nothing but QD cos theta divided by 4 pi epsilon naught into r square. 4 pi epsilon naught into r square. So now we are going to multiply each and every term with respect to this term. So this is equal to, okay, so this is equal to dou by dou r of what? So QD cos theta whole divided by, so 4 pi epsilon naught r square into ar bar plus 1 by r dou by dou theta of QD cos theta whole divided by 4 pi epsilon naught r square plus the third term is 1 by r sine theta again. So 1 by r sine theta dou by dou phi of qd cos theta whole divided by, so 4 pi epsilon naught r square into a phi bar. So sorry, here it is a phi bar, and here we are having one missing term. So what is the term? A theta bar. So multiplied by a theta bar. Okay, so now here, see here, we are doing dou by dou. Dou means in the sense that is partial differentiation. Okay, so we are making the partial differentiation. So whatever the variable it is here, the variable is r. So remaining all the terms will become constant. So here the variable is theta, remaining all the term will become constant. So here we are doing differentiation with respect to phi. So here the remaining all the terms will become constant. So we are going to apply what? Partial differentiation on this equation. Okay, so the value will become, so that is equal to, so see here the variable is r. So we have to differentiate only for r term. The remaining all the terms will become what? Constant. So therefore taking the values of qd cos theta whole divided by, so 4 pi epsilon naught outside of the differentials, that is next we are going to do dou by dou r of 1 by r square of r bar plus 1 by r. So here you are doing with respect to theta, so therefore qd will be the constant, and 4 pi r square is also constant. We are going to do the differentiation only for the theta terms, that is dou by dou theta of cos theta and a theta bar plus, see here we are doing differentiation with respect to phi, and inside this term there is no phi term. So therefore we can make this entire value as 0. So therefore 0 multiplied by of a phi bar. Okay, so since there is no phi term inside of this variable, there will be no if you do the differentiation of this value will become a 0. So therefore 0 multiplied by a phi bar, and you can exclude this in the next coming steps. Proceeding with the derivation again with the next steps, that is equal to, so qd cos theta whole divided by 4 pi epsilon naught, and if you do the differentiation, that value is 1 by r square. So if you do the differentiation, you can have, so minus to the power of r, so minus 2 r to the power of minus 2 minus 1, so the value is minus 2 r to the power of minus 3, the value is minus 2 by r cube if you do the differentiation. So therefore I am writing here it as directly, that is minus 2 divided by r cube multiplied by r bar plus, so see here you are having r term and you are having r square term multiplying. So therefore qd divided by, so 4 pi epsilon naught r cube, and differentiation of cos theta, that is minus sine theta multiplied by a theta bar, and here the value is 0. So therefore I am not writing that. See here if you see the Maxwell's equation, what is the Maxwell's equation? Maxwell's equation is E is equal to minus of del V. So we have to include here minus sign. So E is equal to minus of del V. So here we can have one minus sign outside, and everything should be multiplied with what? Minus. Everything should be multiplied with a minus sign. So now going with the next step, so minus of minus you will get plus, so 2 qd cos theta whole divided by, so 4 pi epsilon naught into r cube of ar bar, and again minus of, so minus with respect to minus sine theta you will get plus again qd whole divided by, so 4 pi epsilon naught r cube of sine theta of a theta bar, sine theta of a theta bar. So here you have the common term qd divided by 4 pi epsilon naught into r cube. So taking that common term, so for taking common, that is qd whole divided by 4 pi epsilon naught r cube as common, you will have what? So 2 cos theta ar bar plus sine theta of a theta bar. Okay, and we know that dipole moment. So formula for dipole moment, small p is equal to q into d. So you can replace the value of q into d with p. So therefore p divided by, so 4 pi epsilon naught r cube multiplied by, so 2 cos theta ar bar plus sin theta into a theta bar. So which is the value for electric field intensity for a dipole. So what is this? So this is the expression for electric, so field intensity for a dipole. Okay, so for a dipole. So that is the thing. So if they are asking, so in your examination, so if they are asking for electric potential due to dipole, means you have to stop your answer with this expression. You can stop your answer with this expression. But if they are asking for electric potential, electric field intensity for a, I mean electric field intensity for a dipole, then you have to proceed these following steps. Okay, so just matter of 2 to 3 steps to be included for the above answer. Okay, so this is about what? Electric potential due to dipole as well as electric field intensity due to dipole by applying Maxwell's second equation. Maxwell's second equation. And we are going into the last and final topic of this year, this thing, that is what we are going to see, the second important concept, that is torque due to dipole. So this thing they have asked a multiple number of times, they have asked many times, torque due to a dipole. Okay, so torque due to dipole. Okay, so try to write down. So first, what you have to do, we have to consider one dipole. Okay, so you have to take one dipole. So if you want to have a first of all, you do, I mean, you people know what do you mean by torque. So torque is nothing but, so if you are having two, so equal and opposite forces. So for example, if you want to open a the cap of a bottle, water bottle, so what you are going to do, so you are going to use one thumb finger as well as your forefinger to tight it or to loose it. Okay, so here by using one thumb finger, if you have to apply the force on clockwise. So similarly, the next finger you have to twist it in opposite direction. That is, one if you are applying, one is clockwise, and you have to do the second one, you have to go with the anti-clockwise direction. So therefore, with the same force but opposite direction. So we'll have a torque. So therefore here, in order to have the torque, definitely we have to have what? The force. The torque has to be have the force. And if you want to create the force, definitely there should be a field. There should be a field. So here, now what you are going to do, we are going to take a dipole. We are going to take a dipole and we are going to place that dipole in electric field. And because of this electric field, there will be a force on this dipole. So because of that force, okay, because of that force, it is going to experience what? Torque. It is going to experience a torque. And we have to obtain the equation for the torque. Okay, so now we are going to see that how we are going to obtain. So for that, what you are going to do, so we are going to take a dipole. So dipole is nothing but what? So two equal, I mean 2 point charges, that is so this is plus q point charge, and again we are going to have another point charge of minus q. And these 2 point charges they have separated by a distance d. By a distance d. Suppose if this is at the origin, So therefore, this value, this becomes what? D by 2, and this becomes D by 2. Okay, D by 2. And this is a dipole. And now what you are going to do? So we are going to place this dipole in an electric field. We are going to place that dipole in an electric field. Now I am going to draw that field. Let us take one more color. Just wait, please. Okay. So I'm going to place this in an electric field. So this is the field in which I have placed the dipole. I have placed the dipole. Okay. Now, because of this field, because of this electric field, okay. Now, the dipole, the point charge, whatever you are having the point charge of plus q and minus q, they are going to experience some force. Let it be the force experienced by this point charge is in this direction. Let it be small f. Let it be f. Since this is plus q and the second point charge is of negative, that is minus q. So just wait 1 minute.
Recording stopped. Recording in progress.
Okay. So see here, with respect to plus q, if this is having the force, if it is having on the right side, since this is of a negative point charge, so therefore this point charge should experience a force which is exact opposite to that of plus q. So therefore here I am drawing this force on the minus q charge as minus f. So since I have written minus f means these two forces are whatever the force here which is experienced by plus point and charge, so will be exact opposite to that of minus q point charge. Therefore here, in order to have that exact opposite direction, here I am representing as minus f. Okay, so minus f. So minus f is opposite direction. To have the opposite direction, here I have included minus f for the vector. Okay. So we know that the equation for torque, the basic definition of torque is nothing but a force given by perpendicular distance. Force multiplied by perpendicular distance. So this is the basic definition for basic equation for a torque. Here the force is nothing but F. Okay, so force is nothing but the F. Here we are having two forces, two torques. One is with respect to plus q and one more torque is with respect to minus q. So let it be. So if this is at point A and if you take this as point B, the torque at point A is because of plus q and the torque at point B is because of minus q. So therefore we are going to have individually, we will obtain the equation for individually, that is TA and TB, and later since dipole is not a single point A and B, it is altogether of A and B, so therefore dipole torque will be TA plus of TB. Okay, so now I'm going to take for TA and later we will go for with TV. So what is a TA? At TA, the force is F multiplied by what is the perpendicular distance? So see here, so this is the perpendicular distance. Perpendicular distance is nothing but d by 2. So if you do multiplication, d by, and we know that force acting on a point charge given by Coulomb's law of force. So that is what F is equal to E into Q. So F is equal to E into Q. Okay, so since at location A, you are having a single point charge of Q. So applying the Coulomb's law of force on that point charge, that is F is equal to E into Q. Substituting the value of F in this equation, that is TA is equal to E Q multiplied by D by 2. So this is equation 1. So where you have calculated, this is calculated at A. Now we have to go with torque at B. So that is TB. Formula is same, that is force into perpendicular distance. Force into perpendicular distance. See here, but here the force is what? The force is minus F. So therefore the force is equal to minus F multiplied by, so what is perpendicular distance? Again, the perpendicular distance is same, that is d by 2. Perpendicular distance is same, so therefore multiplied by d by 2. So this is equal to, now we have to get the force equation by Coulomb's law. So here the point charge is minus Q at B. So therefore what will be the force equation? F is equal to minus
EQ.
E into Q. Very good. So F is equal to minus E into Q, and we are having minus of E into Q, minus of E into Q multiplied by D by 2. So this is equal to minus of minus, we are getting plus. So therefore EQ multiplied by D by 2. So which is our equation 2, where we have got at B. Okay, so now if you want the torque due to dipole. Dipole means both plus Q and minus Q. At plus Q, that is A and B. So therefore torque due to dipole T will be equal to what? TA plus of TB. So what is TA? So TA is EQ D by 2, as well as what is TB? TB is also EQ D by 2. Okay, so therefore torque is equal to EQ D by 2 plus EQ D by 2. So final value is EQ D. D by 2 plus D by 2, you will get D. So therefore EQ D. So torque. And we know that dipole moment formula. So which is given as P is equal to Q into D. So we have already Q into D. So we will replace the value of QD with P. So therefore, what will be the value? So T is equal to E into P. But here, see here, one important point to be noted. We torque is which type of quantity, whether it is a scalar quantity or vector quantity. Torque. Can anyone tell me that the torque is a scalar quantity or vector quantity?
Vector, sir.
Vector, sir.
Is a vector quantity, because see here we are talking the torque whether it is rotating in clockwise direction or anti-clockwise direction. Since we are talking with respect to direction, okay, since we are talking with respect to direction, and as well as magnitude, we have to represent this torque in the form of a vector. Okay, so the torque in the form of a vector. So torque is a vector quantity. So therefore, we have to represent the product, whatever the product term is there, whatever the product term it is there, we have to represent with respect to vector. In case of vector, we are having two types of product. One is dot product as well as one more is cross product. Okay, and we also know that dot product is a scalar product and cross product is a vector product. So therefore, since torque is a vector quantity and we have to represent this torque in the with respect to cross product but not with respect to dot. So therefore, whatever the equation we have got, that is T is equal to EP, we have to take the cross representation. Okay, so we have to go with cross representation. So therefore, final equation for torque due to dipole. So that is equal to T bar. Since I am writing with respect to vector, I am writing T bar is equal to, so E bar cross of P bar. See here, just we are performing the product, but since torque is a vector quantity and again vector products are having of two types, dot product as well as cross product. Dot gives the scalar value and cross gives the vector value. So therefore, excluding the cross, I mean dot, and we have to represent the torque with the cross and representing the torque equation as T bar is equal to E bar into P bar. So which is very much important as a type of question. Okay, so this is all the concepts regarding the dipole. Okay, so we have seen just recollecting. So we have seen what do you mean by dipole, and later we have gone with the dipole moment, and after that we have calculated with respect to electric potential, and later we have gone with the electric field intensity, and finally torque due to dipole. So these are all the concepts that comes under what? Dipole. Okay, so from here to here all are SA type, and from these two we are having short type of answer. Okay, so this is the thing. So here, since we have completed all the topics with respect to the dipole, okay, so here I am ending the session, and again I will restart the session within 1 minute of time. Okay, so you people please do join, so that since if I start the second session there without having any break, we can continue there. Okay, so just we are having 5 minutes again closing and starting, so it will be discontinue, so that we can start a new topic in the next session immediately after 1 minute. Within 1 minute I will start. Okay, so please do join again, all the students.